Hi, it's Professor House. Today I am going to demonstrate to you how you factor a trinomial using the AC method. Now, this method works when you have a trinomial, that is a three-term polynomial, that has a degree of 2. It will work for other trinomials with other degrees, like a third degree or a fourth degree, but those may require additional work, such as taking out the greatest common factor. So today we're just going to focus on those that have a degree of 2. The other thing we're going to talk about is we're looking at trinomials that have a leading coefficient, that is the highest degreed term, the squared term's coefficient, which in this case happens to be 6. We're looking at those that don't have a 1 in front of them. If it has a 1, it will be written, it'll just be x squared, and that's a much easier problem than something like the one we're presented with here. Now, before we factor, let's talk about multiplying binomials. So if I have two binomials, I'm just going to pick a couple at random, 2x plus 5, x plus 4. If I have two binomials, to multiply them, I have to use the distributive property twice. And some of you may recognize this by the mnemonic device, FOIL. Mnemonic device is something that helps you remember a process. For the FOIL rule, the F stands for multiplying the first two. The first two in each binomial. So that's going to be a 2x squared. Then the outer two, 2x times 4, that's the O, that's going to be 8x. The inner two, 5 times x, is 5x. And the last two, 5 times 4, is 20. So here's where the difficulty comes in. Because these are like terms, 2x squared plus 13x plus 20, when you multiply two binomials, you will often get a trinomial. And finding these two numbers in the middle that combined for this middle term is what makes this a little more complicated than some kinds of problems. So all we have to do is figure out what was the O term and the I term of the FOIL rule. Now we know the answer to this one. We have this trinomial, three-term polynomial, and here it is broken into two factors that will multiply to get it. And that's what the process of factoring is. You're changing three numbers added or subtracted to two factors that are multiplied. So let's think about this process for the problem that we're presented with here. So I've got to use what's called the AC method, which is the reverse of the FOIL rule, to find the factorization of this trinomial. Now, where does the AC in the name come from? Well, A is the number in front. That's the coefficient of x squared. C is the number in back. That's the constant. When you multiply those two, you get what we call AC. So 6 times 6 is 36. That's our first important number when we're doing the AC method. This is A times C. Now, the second important number is B. What is the coefficient of the middle term that was created by combining the O term and the I term? So it's going to be for us 13. Now, remember what we have to do here. We have to find the factors, numbers that multiply for 36 that add to 13. Multiply to 36, but add to 13. Now, if your multiplication tables are great and you know all those facts, that's great. If not, you might have to play around for a little bit. But if you recognize 4 times 9 multiplies for 36, and 4 plus 9 adds to 13. That tells you your O term and your I term in no particular order. It doesn't matter what order if you put 9 times 4, that's fine, as long as they multiply for 36 and add to 13. So what we're going to do now is we're going to take these two numbers and we're going to go back to the full format. 6x squared plus 4x plus 9x plus 6. So we're back in the full format before those two like terms were combined. Now we're going to make this simple factoring. We're going to group the first two and the last two, okay? And we're just going to take out the greatest common factor of each pair. Now, some like to use parentheses to demonstrate this, and that's fine. If everything is a plus, you can put parentheses in this problem anywhere you'd like and not change the value of the problem. However, if one of these terms is a minus, particularly that 9, if you put a parentheses after a minus sign, you have to remember that that minus applies to everything, and you got to change all those signs inside the parentheses. So I just discourage that. You don't have to do that. Just mark the first two, mark the last two, or at least think, I'm going to do the first two and the last two together. So I ignore the 9x plus 6, and I go with 6x squared plus 4x, and I take out the greatest common factor, which is 2x times 3x plus 2, because 2 goes into 6 3 times. X times x is x squared. And then for the 4x, 2 goes into 4 2 times. The x is already here. 2x times 2 is 4x. So that's the process, just taking out the greatest common factor. Now, important, whatever this sign is, he has to come down. Just drop that middle sign down there and put it in the middle between your two little greatest common factor problems. So I've got the first pair factored. I go to the last pair, and I notice this time these have a 3 in common. And that leaves 3x plus 2. Now, it's no coincidence that all of a sudden we see some things that are alike. Okay, we have a factor now, 3x plus 2, that is the same in both of our terms of our newly factored 4-term polynomial. Now, but we're not finished, because to be completely factored, you can't have this plus in the middle. It has to be a binomial times a binomial. Okay, so what do they have in common? 3x plus 2. That common factor that you see is your first factor of your answer. And then you look for what's left over, 2x plus 3, and that's the second factor of your problem. Now, we've changed a 3-term polynomial, that's 3 numbers that are added, into the product or the multiplication of a binomial times a binomial, and that's all that factoring using the AC method is. Now, before we declare this to be our answer, we need to multiply it out to check it, okay? It doesn't make sense for you to just write that as the answer without checking it, because checking it's so easy. It's just the full, all right? So 3x times 2x, 6x squared, 3x times 3, so look, first two, outer two, 9x, 2 times 2x, 4x, 2 times 3 is 6, and there's your 4 and your 9 or your 13x. So always, 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 especially if there are some minus signs involved, always check by multiplying those two binomials together before you conclude that that's the correct answer. So we have successfully factored this trinomial into two binomial factors.